environmental parts of the standard, and Monty will focus more on the ENC tests that she performs at her lab. So with that, let's go ahead and get started. The accreditations and recognitions at MET, this is just a small snapshot. We have a very broad scope of accreditation, primarily with A2LA accreditations for our meter test programs, primarily the ANSI C12.1, C12.20. Measurement Canada recognizes us as well for testing previously approved meters. MET is an NRTL, a nationally recognized testing laboratory for product safety testing and evaluation. We are also designated as a telecommunications certification body for our EMC and our telecom test programs here. Our product safety group is also a certification body certified by the Standards Council of Canada, and we are recognized by public service commissions for testing sub-meters as well. And I have listed there the Maryland PSC and the New York State Department of Public Service is just two. So getting into the ANSI program, ANSI C12.1 and 12.20 have basically 38 tests listed in those standards, and you see that here in the table. Any given meter product would not necessarily be applicable for all of this testing. The important thing to note here in this list of tests is there are a set of 8 series tests defined by the standard, and those are denoted by the asterisk there, if you can see that. Those tests, the meaning of the series test is that the same samples must be run through those tests. Not necessarily sequentially, but the same samples without modification need to be run through those tests. You can use different samples of the same make, of course, to run concurrent tests that are not part of the series sequence of testing. So at MET we have basically 4 types of testing programs that you see there. The first one is the ANSI Meter Certification Program, meaning that we'll take a meter type and run it through all of the applicable tests out of the ANSI document. The requirement of the standard is that at least 3 meter samples be run through each test. Now, if you have a family of products that are very similar in design, maybe the currents are different or they have a different voltage range, then the standard does allow you to sort of combine at least one of each type or each feature of that meter family to create your 3 sample set. Sometimes there are more than 3 samples, but at the very minimum, if you only have one type of meter, one type of build, you're going to need to run 3 samples for each test. So at the end of that ANSI Meter Certification Program, we're running all the applicable tests, and you'll get a report of compliance for that. The MET Meter Certification Program is really the ANSI certification program, but it takes it a step further in that we are working with the manufacturer to run annual continued compliance, keeping a check on what changes with the meter product as time moves forward. Are there firmware changes? Are there any hardware changes? And we communicate with the manufacturer to discuss what the changes are and whether or not any previous testing could be affected. If it is potentially affected by the change, then we'll go ahead and pull some samples then for at least partial testing on what could have been affected by that change. And in that way, your buyer would know that, okay, not only did the meter pass, for example, 18 months ago, but changes that have occurred since then are also being looked at by an independent lab, and there's a check and balance there. The customer-specific test program could be anything, really. You may have specific tests out of that ANSI document that you want to run, not the full set of applicable criteria. That's fine. At the end of that type of test program, a report of compliance would be issued specific to the scope of that customer-specific program. And we also offer a pre-test program. It's very quick. Some of the tests are truncated. We usually run just one sample through that. And the idea is we sort of focus on the more problematic tests, the tests we see non-compliant first time through more often than not. And that can be effective, especially with a new meter product, to get a quick glimpse of what could be a problem before you get into the full test program and then encounter a failure and have to rerun tests that have already been completed. So that can be quite a useful program as well. So the core of the MET Meter Certification Program, when a customer comes to us with a meter product, we have a specific request for quotation form and some very detailed questions about the meter itself to give us an idea of what the product really is, how it's to be installed, what features are on the product, and we'll take a look at that, analyze what we're going to have to do during the course of the test program, and come up with a quotation and a test plan for that particular meter product. Again, 3 samples at a minimum need to be submitted for testing for each test. Most of the time we'll ask for more samples than that. We may ask for 12 samples, 15 samples or more in order to help expedite the test program, where we can break the samples into 3 sample sets, for example, and start, a set into the series set of tests and run some other concurrent testing on other 3 sample sets. At the end of that successful testing program, you get a report of compliance and a certificate that has all the details in the report on how what the meter was about, what samples were tested, what firmware revisions were a part of the meter, any communication modules, how the meter was monitored. All the details are in the report, and the certificate is really just a quick one-page certificate detailing that the meter was, or that family was compliant for testing to the ANSI C12 document. We maintain a database of certified meters on the MET website, which can be useful when you're talking to a buyer. They can glance at that list and see that you're on there. Again, with the MET Meter certification, there's a continued compliance portion of it to make sure that any changes are not affecting previous compliance. That's only for the MET Meter certification. If you're going through an ANSI certification only, you wouldn't be concerned with that piece of it. And again, MET's reviewing all of the firmware revisions and hardware modifications that occur to the product as time moves forward. There's always some sort of change, and we're just keeping a check on that and discussing what may or may not have been affected by those changes. So the ANSI documents are really written for revenue generation utility meters, socket meters, A-based meters. And when we're looking at a test program, we want to make sure that all the features of the meter are exercised properly, so that everything's covered in the report, and there's no question about, well, was the AMI module transmitting at full power, that sort of thing. It'll all be in there. We are making sure that we have the communications, the proper communications programs. We're asking always that the customer supply us with support equipment. Typically that's a laptop loaded with software so that we can communicate with the meter it's not just about plugging the meter into our meter accuracy test boards and reading the register off the display. It's also communicating with the product to make sure that's functioning well, and that the registers, the software registers, are tracking with the meter as well. Again, any communication modules, AMI modules, MR, they've got to transmit at full power to make sure that the accuracy is not going to be affected by that higher power. If we see problems, at times we may test with and without exercising those communication modules. Service switches that may be embedded in the meter, we see those very often these days, and we want to make sure that we can actuate those, again, usually using the software provided for communicating with the meter. So you're making sure that there are no problems there. And even though the standard is written really for the revenue generation utility type meters, sub-meters, the public service commissions tend to, more often than not, have criteria that defaults back to the testing against the provisions of ANSI C12. So really, sub-meters are subjected to these tests. When we're taking a look at what the sub-meter is, what the application is, we really have to be creative sometimes in coming up with a test plan that covers the criteria in the standard, but is sort of tailored to what that sub-meter is all about. So that can be challenging at times, but we work with the manufacturer as well to come up with a solid test plan that covers all the features, but is not going beyond what the sub-meter is really designed for. So once you've gone through the initial program, again, if you have modifications to the meter, we've got to, I touched on this earlier, we've really got to take a look at what those modifications were. It's really a case-by-case situation, depending on the type of product and what the modification is. And we collectively get together here at MET, again, with the manufacturer's input at times as well, to come up with a good judgment on what the modification could have previously affected in terms of the compliance that was performed in the past. So sort of when in doubt, we're going to request that certain tests be rerun in order to prove out that the meter is continuing to be compliant. So again, the meters it's a case-by-case basis, really. There's no one-size-fits-all. And we do solicit the manufacturer's input on, particularly with firmware changes. Many times it may not affect the previous testing in terms of the accuracy, so that may not be something where we need to see any additional tests take place. But generally, the changes we're seeing are firmware, some hardware changes. Maybe you're sourcing parts from a different manufacturer or had PC board changes. These types of things could affect certain types or certain tests out of the document. Some of the conditions just in general that affect the accuracy that we see here, the temperature, humidity cycling, particularly at the extremes, can cause the meter to wink out and no longer be functional. Noise or interference created by the communication modules internal to the meter, we've certainly seen those problems. The current faults or line voltages many times may cause issues. Service switches seizing up and no longer becoming functional or even fragmenting at times. Improper calibration of the meter at test amps. So we run an as-received test sequence, full load, light load, power factor when we first get the products, just to make sure that the meters are properly calibrated at test amps and also at the light load and 0.5 lagging power factor as well. You want to make sure, again, that the modules internal to the communication modules are transmitting at full power internal to the meter. Harmonics certainly could affect the accuracy of the meter, although for the ANSI program at this time, there are no harmonics tests that are listed as criteria, but that could change in the future, and I think very will likely change. Corrosion, water ingress, vibration. We've all seen these types of things cause problems with the meter and affect accuracy. From my lab's perspective, the accuracy and the environmental, some of the problems we see more often happening are the meters coming in either not properly calibrated, they're out of tolerance at that full load light load power factor, or perhaps they don't communicate properly before the test. When we see that, we're catching it right away and not getting into the test program. Occasionally running the full range of the load performance testing or the power factor conditions, test 3 and 4, we'll see either the low end or the high end cause problems in terms of not meeting the limits given in the standard. Again, with the service switches, we have seen problems with the overcurrent testing, test 20, where they seize up, and really that 7,000 amp, and that's a 7,000 amp peak overcurrent surge for several cycles. You've got to be able to survive that, so the switches need to survive that. There's actually also an additional technical requirement, C12 TR30, that has some additional focus on the service switches as well that could be run, although it's not necessarily part of C12.20 or 12.1. But it could be a situation where your buyer would request those types of tests be run as well. Operating temperature, talked about that, particularly at the extremes. The vibration, the mechanical or the transportation vibration and drop in particular could be an issue. Many times we see that the packaging of the product, those two are packaged tests, the package vibration and drop. The packaging, if it's inadequate, you could have damage to the meter, whether you're having tabs break off on external, cracked domes, cards coming loose or breaking brackets internal to the meter, standoffs. We see that sort of damage with improper packaging. The mechanical vibe is really more like an office vibration test. We don't see problems with that too often, although occasionally we will see, say, a component, maybe a larger component shear off of PCB. Discoloration or fading of the displays or external parts of the meter during the weather simulation test. We see that occasionally. The water ingress, too often with the rain test, or every once in a while, not too often, but every once in a while we'll see the water test fail, that rain tightness test. Meter losses, we'll see that be out of tolerance, typically with the communication module, say on one meter internal, although those modules are allowed to be removed to make that measurement, but we'll still note that needed to happen in order to be compliant with that particular test. So with that, I'll go ahead and turn it over to Monsi to discuss the EMC side of the test program.
Thanks, Jim. Good afternoon. My name is Monsi, and I'll be speaking about the EMC-specific tests that are called out in the ANSI standards. So as you can see, there's a list of the EMC-specific tests that are called out in ANSI C12.1 as well as ANSI C12.20. Now, if you're an equipment manufacturer, you may have seen or come across some of these tests because they are required, or most of these tests are required as a part of CE marking. But there are some tests that may seem unusual or that stand out because they are only ANSI specific. And those tests are test number 18, effect of external magnetic field, and test number 21, effect of current surges in a ground conductor. So the external magnetic field, what this test is it calls out to run the test as a magnetic test, a magnetic immunity test, wherein 100 amperes of current is flowing through a 1 meter coil, and the equipment or the meter is situated about 10 inches away from this coil with all the current circuits loaded, with all the communications happening, and the meter is basically functioning as a fully functional EUT, and the test is run on all axes of the EUT. The other test that is different in this spec is the current surge in ground conductor. Now typically you may have come across surge testing which simulates the lightning strike that is done for any European testing, and that test calls out for a surge spec of 1.2 microseconds by 50 microseconds, wherein the first number is the rise time and the second number is the half time of that surge. Now this surge is different because this surge is trying to simulate a lightning strike that happens to a ground rod that is nearby where the meter is situated. And the way it's different is that the rise time is a lot slower. It's 20 microseconds as opposed to 1.2 microseconds, as well as the test level that's called out. So this test we're required to perform it at 20 kiloamps. Most of the other tests are very similar to the other IEC standards. The only difference is that the surge test, that's test number 17, which is called out, it's required to perform this test at an amplitude of 6,000 volts. Now normally, most equipment manufacturers are required to perform testing at 1 kilovolts, 2 kilovolts. Sometimes the max that one could go to is 4 kilovolts. But here we are required to perform up to 6,000 kilovolts. And not only are we required to perform the test at 6,000 kilovolts, but most importantly, the impedance is 2 ohms, making the current combination at 3,000 amps or 3 kiloamps. All right. So let's talk about some of the common EMC test failures. And the most common EMC failures we see here in the lab are the leakage current, which exceeds 5 milliamps. Now this is the insulation test, which is part of the series test that Jim alluded to. And what this test is we test for the insulation between various coupling paths in the circuitry. We test the product at 2500 volts RMS for 1 minute, and we measure the leakage current. And this leakage current is required to be 5 milliamps or less. And most times this is the test that a lot of products fail, and we'll get to why they fail in the next slide. The other issues that we see are component damages or watt-hour readings increased during high voltage surge tests. So what we see during this test are burnt out components, burnt out tracks. Sometimes we see that the watt-hour readings that we are required to monitor during the test, we see that these readings randomly fluctuate and increase. The emissions measured exceed SCC Part 15 subpart B limits. So as a part of the ANSI test suite, we are required to test at least a minimum of 3 samples for conducted and radiated emissions. And we test the product for conducted and radiated emissions according to SCC Part 15. But the test setup is different for ANSI. Instead of a regular setup, we are required to have a specific length of the cables exposed on the tables, and the product is powered via listens that are also situated within the chamber. So emissions is one of the things that we see fail a lot in the lab. We also see that the kilowatt hour or the watt hour readings on the display changes by more than 1 least significant digit during radiated immunity test. Now during this test, we are not required to power the current circuits, so the current circuits are left open. Only the voltage is going through to the meter, and any other communications or that we are required to monitor, we monitor that during the test. So sometimes as a result of the test, which is a field of about 15 volts per meter, we do see that the display increases by more than what is called out in the spec. We also see AMI/AMR module damage as a result of the testing. Sometimes we see manufacturers who retrofit previously tested meters with AMI/AMR modules, and the meter manufacturer then hands over a list of the tests to the AMI/AMR module manufacturer, and they come to us for testing. And sometimes we do see that everything seems okay during the test, but after the test, when you check for functionality, the AMI/AMR module functionality ceases to exist. We also see sometimes that the post-test accuracy check is out of tolerance, and we do see this happen sometimes during insulation test or surge test, wherein everything seems fine. The leakage current measured is in spec, it's less than 5 milliamps. The surge test, everything seems to go fine. The display does not change. There does not seem to be any obvious component damage. And when we try to perform the post-test accuracy check, that's when we discover that something is wrong because the accuracy check fails to meet the requirements. So what are some of the things that you should keep in mind when you're testing for AMC on smart meters? Is the product that is sent for testing a good representation of a typical installation? Now on the same page you can see a photograph, a setup photo for radiated emissions on a sub-meter or a smart meter. Now this typical meter, what it does is it's supposed to be mounted close to a breaker panel, and where the current circuits or the current sensors are inside the breaker panel, and the metering box resides close to the breaker panel. So when you submit your product for testing, you need to be aware how your product is going to be installed, and you need to provide us with the adequate shielding, with the adequate enclosures that are representative of a typical installation. Because sometimes we see that we just get a product wherein there is a lot of cables or bare wires coming out of the metering box and connected to CTs, and they do cause emissions and immunity failures. Is there any voltage sensing circuitry that needs to be disabled for insulation testing? So when we perform insulation testing, we perform it across various coupling paths like line 1 to ground, so on and so forth. And we do ask manufacturers before we perform this test, hey, do you have any MOVs, any supplies, any transformers that are in line in any of the coupling paths that we are about to test? And if so, we ask them for the locations, and we then remove those components before we proceed to perform the test. And in cases where we cannot do so, we don't perform tests on that typical coupling path. But that is something that we need to know before we perform the test. Will the design withstand 6 kilovolts, 3 kiloamp surges? So this is something that you need to cross-check your design to see if it will meet the 6 kilovolts level. Are your MOVs or other arresters designed to meet the spec? Does the meter use PLC to communicate with the utility, and has this been communicated to the lab? Now this is something that happens a lot of times that we see here, wherein we are performing conducted emissions testing on a product, and the emissions obviously exceed, and then we try to figure out what could cause that emissions to exceed. So we ask the manufacturer, hey, what do you have on your circuitry? Do you have any power line communication going on? We need to know beforehand, we need to know what frequency it operates at, because there are different requirements if you have a PLC on board. So that is definitely something that we need to know. Is the AMI/AMR module pre-certified, and has it gone through RNTTE directive testing? So any radio modules that you're integrating on your product, you want to make sure that they are already pre-certified. Now you would think that since you're testing your product against ANSI for the US market, all you need to make sure is that the product is certified for SCC Part 15 for intentional radiators. But it does make sense to cross-check and verify that your AMI/AMR module is also designed to meet the European requirements, and it also meets the RNTT directive testing, wherein the product goes through the EMC test for the intentional radiator. So it will give you a lot of confidence when performing tests like fast transients or surges to a limited capability or ESD and other such tests. So what are the things, some of the things that you could do before sending your product in for testing? Get familiarized with the standard test setups and requirements. As I've mentioned before, for some of the emissions and immunity testing, the standard setups called out in the IEC standards do not apply. ANSI requires some very specific test setups for conducted and radiated emissions and radiated immunity. So it definitely behooves you to get familiar with those setups. Evaluate your product against ANSI test requirements right from the design stage, because there are these unusual tests, the magnetic field test and the current ground surge test that you may not have come across in any other specs. If your product is a sub-meter, get together with your buyers and get the test plan approved for the applicable test. A lot of times this is a necessary step because, for example, let's say your product is a sub-meter that resides on a pole somewhere. Do you really need to perform an insulation test? Maybe not. But that is something that you need to go through with your buyer and get your test plan approved. And use the pre-testing option on high-risk tests. This is something that Jim mentioned as he was speaking previously. You know, if you're not sure of your design, if the design is untested, you can bring your product. We can sit through, discuss a test plan, and come up with some high-risk tests based on your design, and we can perform pre-testing for those specific tests. Thank you. I'll now hand over to Jim.
Okay, thanks, Monty. That is the overview of our ANSI Meter Certification Program in terms of the ANSI C12 testing for accuracy, the EMCPs, the environmental Ps. We do have optional test programs that may be useful as well. And here's a glance at some of those. As I said, we're an NRTL for product safety compliance program. We do offer HALT and HAS testing, the highly accelerated life testing in particular we perform here. The stress screening program is normally something that's done on the production units at the manufacturer, but we could offer that as well and certainly offer guidance toward it. Failure evaluation, whether it's a manufacturer of the meter or a utility that's seeing problems in the field, we do offer help in trying to hone in on what the problems that you're encountering may be and try to design a program that would simulate those problems that you're seeing in the field. Our FCC certification program, our wireless group, also performs testing on the communication modules. So if you need that sort of service, we offer that here as well. And CT testing for accuracy of CTs. We also offer that sort of a test program here. So just a little more detail about each. The Product Safety Certification Program and RTL were OSHA approved to test and certify meters under the UL 61010 testing standard, as well as the Standards Council of Canada, CSA C22.2. We can also provide test service for the new, relatively speaking, new UL 2735 safety standard for electric utility meters. We're also in the queue with OSHA to get approved, actually have them recognize that standard and put us on the list for that approval as well. They're still reviewing that. An NRTL program would require inspections, actual 2 inspections annually, where our group would come in and take a look at the quality program and the builds of your meter products. Again, this is not necessary for the ANSI test program, but it could be something that a buyer requests, and certainly we have the type of service here for you if you need it. The HALT task, again, we have that program here, and really that's about trying to uncover design flaws, problems, weak parts of the product itself, and it doesn't have to be a meter, it can be anything really, but the whole idea is to sort of agitate the product to the point where it breaks, to again uncover these weaknesses, correct that problem, and move on with the testing. There's no necessarily set test program for it. The idea there is you're uncovering weaknesses in the product. At the end of the program, at some point, you'll be assuring yourself that you're coming out with a ruggedized design. Utility concerns. Again, this could be manufacturers as well, but problems that you're seeing in the field, things that tests that we could develop here that would go beyond what's an ANSI, wider temperature ranges, longer durations, anything that we might, the manufacturer or a utility may come to us and talk about seeing in the field, and we would try to develop a test program here to simulate those events that they're seeing in the field and try to uncover what the problem may be. We certainly can help you with a test program such as that. The CT accuracy testing, the IEEE C57 13.6, IEC standards, as well as the ANSI C1211, all primarily having to do, our focus here really is the accuracy of those CTs. We can offer those types of programs as well. I put in here some changes, some upcoming changes. The C12.1 standard has been undergoing some revision over the last couple of years. Really, it looks like it may be close to being released as a 2015 revision. And just some of the highlights there, that'll be changes to that standard. There's going to be a 0.5 accuracy class in there now, whereas traditionally in the past, the C12.1 standard was really considered a 1% accuracy standard, a 1 accuracy class. There's some expanded definitions, particularly on balanced voltages, higher accuracy criteria, tightened accuracy criteria for both portable and reference standards used for testing meters in the field or in the lab. A bit of clarification on the performance requirements prior to getting into a test program. I mentioned earlier we run an as-received set of tests that determine the accuracy of the product before any external influences or any tests are run on it. And there's been some clarity added to the standard to help folks understand what the criteria is getting into a test program. So test 5, test 9, there's been some changes there, eliminating empirical rise calculation that was in that is currently in the existing document, going more with a fixed limit for temperature rise, some direction on where to measure those rises on the meter jaw, the meter socket jaws. Test 17, line surges, they're the ring wave and the combination wave that Monty's group performs. There's been a bit of relaxation in terms of allowing an accuracy check of before and after full load, light load, power factor. Accuracy check to be performed before and after the two of those surge events rather than after each. Just helps quicken the pace along a bit. Test 25A, there was a typo really in the document all along, and it talked about a 2-minute duration for that test, and really it's a 2-second duration, and that harmonizes it with other industry standards. Test 30 and 31, that's the operating temperature and the relative humidity. They're similar to test 17. You're now allowed to run the two of those environmental temperature and humidity sequences together and run an accuracy check before and after. You're also looking at the accuracy during these events as well, but it's required that you run an accuracy check before and after. You're allowed to do that now after performing both rather than after each. And there's been some updated guidance, quite a lot of change really to Section 5 regarding the in-service meters, primarily used criteria that's used by the utilities to run annual checks and so forth on meters that are already in service in the field. And some update on the periodic test schedule, again, sort of follows along a bit with Section 5, but the test schedules for AMI equipped meters versus other types of meters. So just some highlighted changes there that is coming to the new revision of ANSI when it is released. We do offer other test programs. I mentioned the Measurement Canada program under the RTO1 program in Canada. That's actually the only test lab that's approved or recognized, I should say, by Measurement Canada for performing tests and having that data recognized by Measurement Canada. It's a little restrictive in that it's only for previously certified meters, and we're still following the test plan that's provided to the manufacturer by Measurement Canada directly. However, we can help out and generally get those tests done, maybe a little quicker fashion than if you get in the queue with Measurement Canada. We also test quite a bit of meters that are going to be sold in Mexico under the CFE standards. And what we're seeing there, where traditionally those standards in the past have been very much like the ANSI C12 standard, there's been some changes where they're really harmonizing a bit more with the IEC type testing, where I like to say it's sort of the same. You're looking for the same things, but they go about it a bit different, and there's different test points and so some different types of tests that are run as well. So we're seeing the Mexican standards really evolve toward harmonization, more so with the IE standards and not so IEC standards, and not so much with the ANSI any longer. And then there's the group of the IEC tests that we also offer in terms of test programs for more global compliance, international. So just sort of wrapping up the benefits of MET Meter Certification Program, you've got the third-party unbiased evaluation by a recognized test lab. Coming to MET, you're ensuring that with the communication amongst ourselves and with the manufacturer, that your meters are going to be consistently subjected to the standards and not have one be subjected in one manner and another be subjected in a different way. Monitoring changes with the MET Meter certification, monitoring any changes to the product over time to make sure that previous compliance is still going to be within the limits of the standard. Coming to, obviously, an independent test lab gives the public confidence that the meters have been tested and it's not just the manufacturers say so, so to speak. So that could help out as well with marketing and public confidence. Industry knowledge here, the folks that work at MET is something that we tout. We stay on top of the standards, and we're working on certain committees and groups to keep up with the progress there. And the customizable test programs for anything really, whether you need partial testing to a standard, full compliance, or you're seeing some problems in the field, that we may be able to come up with a test plan to determine what may be happening in the field. That's something we can help out with as well. So that really wraps up the webinar. There's an email, a phone number there, and here is actually more. So I guess at this point we can go ahead and take any questions you may have.
So as Jim said, that concludes the presentation portion of the webinar. Tomorrow, an archived copy of this webinar will be available on metlabs.com, and we will send a follow-up email with the link to this file. Now we will answer questions. If you have a question, please type it in the questions area of your control panel. For questions we can easily address now, we will read the question aloud and then give the answer.
Okay, so I see a question here. Will you be able to do full measurement candidate testing for products not previously tested? Unfortunately, at this time, the scope of the RTO1 program in Canada does not allow full testing on a new product. It's got to be a product that's been previously certified. Now, if you're going to sell to Measurement Canada or go through Measurement Canada for sale of products in Canada, you could, I would say, discuss the matter with the folks at Measurement Canada, and there may be some allowance for performing certain sections. For example, testing. It's hard to say. Some dialogue, if you open some dialogue with the folks at Measurement Canada, there could be a bit of relaxation there, but really it's a government entity, so by law we're not allowed at this time to run any testing on that would be accepted by the folks in Canada, mind you, on meters that were not previously certified by Measurement Canada. It's not to say that we couldn't run a test program, but if it's not previously certified, it would not technically be acceptable at this time.
So there's another question. Isn't it 20 by 50 milliseconds, not microseconds? It's actually 20 by 50 microseconds. So what I've written on the slide is correct.
So there's a question about when the 2015 ANSI standard would have to be used. Generally speaking, I'm trying to think if there will be a transitional period. Generally speaking, once it's released, it pretty much supersedes the old standard, and at that point, you would want to go ahead and use the latest revision of that standard. I don't think there's any long transitional period, but that could potentially be something to look for. But I would say that once it's released, generally it's superseding the old standard pretty much right away. Okay, so there's a question regarding the CFE test programs. Is MET involved in the CFE function testing during the certification test programs. No, we are running the prototype testing programs. The functional testing that's sort of a different section of that standard is not part of what we get involved with. We run through the accuracy, environmental, and EMC portions of the prototype testing requirements out of that standard. Okay, another question in is the new standard, the ANSI standard, I suppose. 1% relaxing the accuracy requirement or making it more difficult to pass. No, it's really the 1% accuracy class, the 1.0 accuracy class is still in the standard, and there's also a 0.5 accuracy class set of limits in the standard. So the limits that are presently in the C12.1 standard remain in place as a 1.0 accuracy class, and then there will be an additional set of limits for a 0.5 accuracy class where that is more stringent and essentially follows along with what's currently in ANSI C12.20 for 0.5 accuracy class. So to answer the question, the 1% limits that you see there now are going to remain in place. They're simply adding another accuracy class to the standard, which then has the tighter limits for the accuracy testing, if your meter happens to be a 0.5 accuracy class meter.
If you have any additional unanswered questions, please contact us via phone or email. Tomorrow we will send a follow-up email that will include a link to the presentation. That concludes our webinar, and thank you for joining us today.